This video is going to talk about functions, and before we define what a function is, I want to look at another term here, which is a relation. And a relation is simply a set of ordered pairs. And keep in mind, what do we mean by the word set? Well, if you recall, when we talked about our whole numbers, we said that the set of whole numbers would be 0, 1, 2, 3, 4, and so on. So in other words, our set is just representing all the numbers or all the elements that make up that set. So the set of whole numbers would be 0, 1, 2, 3, 4, just like the set of integers would include all of our negative numbers, such as -4, -3, -2, -1, 0, 1, 2, 3, and so on. But realize the integers, remember, they do not include decimals or fractions. We're only looking at basically your whole numbers and then the negative of those values. So here, when we talk about a relation, we're looking at a set of ordered pairs. So an example of this might be if we have now an ordered pair, we're looking at our x and y, so we could have 1, 2. So this is one of the elements or part of the set. And then we can have another element, which would be 3, 4. And we could have 5, 6. So this is just simply what a relation is. It's simply a set of ordered pairs. Another term you might want to use, it's a collection of ordered pairs, but mathematically we call this a set of ordered pairs. So that's really all that a relation is. Now, the reason I mention that is because when we look at the definition of a function, they're going to use the term relation. So here, a function f from set A to set B is a relation. So what does that mean? Well, that simply means that a function is made up of ordered pairs, where you're going from set A to set B. And a lot of times when we think of set A and set B, we're thinking set A is typically representing our x values, set B is representing our y values. So a function is a relation, so that means a function is a set of ordered pairs that assigns each element n x, the set A, exactly one element y in the set B. Okay, so basically what that means is A is made up of all these elements, so there's an element x, some x value in set A that is matched exactly with one element in set B. The set A is the domain, okay? The domain or the set of inputs. And again, when we think of set A, we're talking about our x values. So A is the domain of our function, and set B contains the range, which sometimes we call the outputs, or for us, the range we know typically that is our y values. Now, first, this definition sounds a little confusing, so let's go through it one more time. And then we're going to go down here and look at what we call the characteristics of a function from set A to set B. And this is going to better define what we're talking about in terms of a function. So a function f from set A to set B is a relation, so that's a collection or a set of ordered pairs that assigns to each element x in the set A exactly one element y in the set B. The set A is the domain or the inputs of the function, and set B contains the range or the set of outputs. So if we go up here and use this example above, we have 1, 2, so we could think of this as our x and y, okay? So in other words, x is the domain, y is the range. So we have here 1, 2, 3, 4, 5, 6. So if I kind of set that up here in kind of a visual explanation, if this here represents set A, and that makes up our x values, or what we sometimes refer to as our inputs, then if we use the example above, our x values up here are 1, 3, and 5. So here A is made up of 1, 3, and 5. Okay, so once again, this is our domain. And then if we have another set over here, which we'll call our set B, then we could think of this as our y values, or the outputs, which would represent the range. Well, if we go up here, our range then would be the y values, which are 2, 4, and 6. So down here we would have 2, 4, and 6. And here we match up with 1 is paired with 2, 3 is paired with 4, and 5 is paired with 6. And that matches up here, 1, 2, 3, 4, 5, 6. So 1 is paired with 2, 3 is paired with 4, 5 is paired with 6. So basically what that says, if you take and plug 1 into our function, then you're going to get out 2. If you plug 3 into the function, you get out 4. If you plug 5 into the function, we're going to get out 6. Now let's see if we can go through these characteristics here of a function from set A to set B. Now the first one says each element in A must be matched with an element in B. Well, if we look here, is every element in A matched with an element in B? Well, the answer is yes. Every element A, 1, 3, and 5, is matched up with another number over here, 2, 4, 6. Okay, so that checks out. Now, what would happen if, well, I'll make another one over here. This is one we'll kind of work with and change around a little bit. If I was to give you the following, if we had, let's say, 1, 3, 5, and over here we have 2, 4, 6. Now, if I was to pair 1 with 2 and 3 with 4, and we'll get rid of this number here. Now, does this satisfy number 1? Each element in A must be matched with an element in B. Well, if you notice here, the 5 is not matched up with any element over here in set B. So this here is not a function because every number in set A has to be paired up with a number in set B. So this over here is not a function. Okay, so that's what we're talking about, where A has to be paired up with every element over here. Every number, 1, 3, 5, has to be paired up with a number in set B. Okay, so that's the first characteristic. The second characteristic says some elements in B may not be matched with any element in A. Well, that means if we have, for example, 2, 4, and 5, if we match up 1 with 2 and 3 with 4. Now this is kind of the opposite of what number 1 says. Some elements in B may not be matched with an element in A. So if you notice here, this is okay. We have 1 paired with 2, 3 paired with 4, and notice we have 5 over here that's not paired with anything. Well, based on characteristic number 2, that is okay because it says some elements may not be matched with an element in A. So it's okay basically if you have extra y values or numbers over here in set B that aren't paired up with anything, but you cannot have extra numbers in your set A that are not paired up. Okay, so there's an example of the second characteristic. The third characteristic says 2 or more elements in A may be matched with the same elements in B. So what does that mean? Well, if we have 1, 3, 5 and 2, 4, 6, if we were to pair 1 with 2, 3 with 2, and 5 with 6. So 2 or more elements in A may be matched with the same element in B. So that means here we have 1 paired with 2 and 3 is paired with 2. And that says that's okay. And then we have 5 paired with 6, and once again, it's okay that we have 4 that's not paired with anything. But property 3 here, characteristic 3 says that it's okay if we have the number 2 here being paired with 1 and 3. Now, let's be careful with number 4. What does that tell us? Well, number 4 says that an element in A cannot be matched with 2 different elements in B. And this is probably the one that most people are familiar with when they're looking at the characteristics of a particular function. So if we have, say, for example, 1 and 3, and over here we have 2, 4, 6, and then we pair 1 with 2, and let's say 1 with 4, and 3 with 6. Now again, this is kind of the opposite of what number 3 stated. Here we have 1, which is in set A. This is your input, or the domain. 1 is being paired with 2, and 1 is being paired with 4. And this is probably what most of you used to refer to as having what we call a repeated x value. In other words, we have 1 paired up with 2, and 1 is also paired up with 4. And this is where we would say we cannot have repeated x values, otherwise this is not a function. Now it's okay to have repeated y values like we just looked at in the previous example I looked at here, but we cannot have repeated x values. Okay, so this would not be a function. So over here, all 4 of these characteristics must be met in order to have a function. So if we look at our example now over here on the left, does this example on the left match up with all 4 characteristics? Well, each element in A is matched with the element in B. So we've paired 1, 3, and 5 with something over here in set B. Some of the elements in B may not be matched with any elements. Well, that means we could have extra numbers, but we don't have any, so that's okay. We have 2, 4, 6, and they're all paired with a number. 2 or more elements in A may be matched with the same element in B. Well, that means that we could have 1 paired with 2 and 3 paired with 2, but so everything seems okay there. And then 4 says, again, we can't have a repeated x. We can't have something in A paired up with 2 different elements in B. Well, everything in A is matched up with exactly 1 element in B. So this example here, this is an example of a function. Okay. So hopefully now you may need to go back and read through these characteristics and understand what we mean by defining what a function is representing. And one of the main ones that we typically look for is the number 4 here, where you do not have repeated x values, but you still need to make sure that you remember the first 3 characteristics. All right, let's look at a couple examples here, and let's see if you can determine whether these examples represent functions or not. So here we have a set of ordered pairs, 4, -8, 3, 7, 6, 1, -1, -8. Does this represent a function? And you may want to pause the video and see if you can determine this. And when you're trying to determine if this represents a function, remember, we need to make sure that we meet all 4 of these characteristics. Well, if you look closely here, we have 4, -8, 3, 7, 6, 1, -1, -8. Do we have any repeated x values? No. Now, if you notice, we do have repeated y's. We have a -8 and a -8, but that's okay, isn't it? So it looks like here, this does represent a function. It does meet all of our characteristics. Every element in A is matched with the element in B. Some elements in B may not be matched with any element in A. Now, because we don't really know the sets here, we're going to assume that we're using all of A and B. 2 or more elements in A may be matched with the same element in B. That's what we're looking at here with number 3, where 4 is paired with -8 and -1 is paired with -8. Once again, it's okay that we have repeated y values. Okay? So this is an example of a function. What about this one? We have set A going to set B. 9 is paired with 13, 2 is paired with 10, and here 4 is not paired with anything. So an example of this is if you want to rewrite this, we could rewrite this as a set of ordered pairs. If that's easier for you to see, we would have 9 matched up with 13, 2 is paired with 10, and here comes the problem. We have 4, but it's not matched up with anything here. So because of that, what does that tell us? Well, hopefully, if you go up here to our characteristics, it says each element in A must be matched with an element in B. So therefore, we have an element in A that is not matched up with the element in B, so this is not a function. All right, and one more example. We have set A to set B. 15 is paired with 12, 15 is paired with 9, negative 4 is paired with 25, and 3 is paired with a negative 2. And hopefully you can see something here that's going to give us a problem. And again, if you need to, we could write this out as a set of ordered pairs. We have 15 paired with 12, and then we have 15 paired with 9, negative 4 is paired with 25, and 3 is paired with a negative 2. And at this point, hopefully we can realize that our problem occurs here where we have 15 is being paired with two different y values. So this is example here where we have repeated x values, so therefore this is not a function. All right, so hopefully now you have a little bit better understanding of what a function is. And recall, let's go back and look at the definition we started with and see if it makes a little bit more sense to us now. A function f from set A to set B is a relation, so that simply means it's a set of ordered pairs that assigns to each element x in the set A exactly one element y in set B. The set A is the domain or the inputs of the function, and set B contains the range or the set of outputs. So make sure that you go back and read the definition and understand what we talk about for a function, and particularly make sure that you understand all of these characteristics here, and you will easily be able to identify which set of ordered pairs are functions and which are not functions.